In this video, we'll take a look at IUPAC naming. So, in case you're curious, IUPAC stands for the International Union of Pure and Applied Chemists. It's basically just a congress of chemists who came along and invented this nomenclature that we're going to use and introduce in this video. So, with that, what you need to know from IUPAC naming is that it's a systematic naming convention for all organic molecules. So the point is that anybody using this naming convention can look at any molecule and name it the exact same way under these very simple three set of rules that allows you to name any organic molecule. So with that, we'll get right into the rules. So the first rule is identifying the longest chain of carbons, of continuous carbons, containing the functional group if there is a functional group in that molecule, and then name that chain. So here are the names for a standard chain of alkanes. So one carbon chain is the prefix is meth, 2 is eth, 3 is prop, and so on. So I recommend you screenshot this this part of the video if you want to use it for the future questions that we'll look at. But the point is you need to be able to recognize from these names the number of carbons that are in that chain, that continuous chain, whatever it may be. So then the next rule is the lowest numbering system. So what this means is that within the longest chain, you need to choose the longest chain that has whatever substituent. So like substituent just means a branch. Whatever branch or substituent is at the lowest number in that continuous chain. So for instance, if you have an option between having a substituent or a branch at carbon 2 or carbon 7, you would need to pick the one that has it at carbon 2 because that's consistent with the lowest numbering system, which is our rule number 2 here. All right, and the last rule is that rule number 3 is substituents, again, our branches, are listed in alphabetical order, not numerical order. So as I mentioned in the previous rule, we're going to be identifying these substituents at their position in the chain. So when you list that in the final name, you have to record them in alphabetical order, not in the numerical order from the chain designation. So this is a lot of semantics, so we'll get into an actual example to illustrate what you need to know and how you need to apply these rules to an actual question that you may be asked on an exam or homework assignment. So here's an example. This is just a standard alkane. So the first thing I like to do is identify the functional group that is involved in your molecule, if there is any. So in this molecule, there isn't a functional group. The functional group is simply just an alkane because it's all just carbon and hydrogen atoms. So here, the best way to think about this is the alk in this generic name is the placeholder for the number of carbons, right? So if we go back to rule number 1, it was like meth, eth, prop for the number of carbons. That's simply in the molecule that you have, you replace alk with the meth, eth, prop, or whatever it is, the number of carbons will go there. And then the second part, the suffix, is the functional group for that particular molecule. In this case, it's just an ane because they're all just carbon, hydrogen, carbon, carbon single bonds. So you don't need like alkene is carbon, carbon double bonds, and etc. all the different functional groups. So here we just have an alkane. So that will be our suffix. So now we move to rule number 1, which is what's our longest continuous chain of carbons. And we have a couple options, right? The most obvious one, if you just like look at this like you're reading, you would go left to right. So this would look 1, 2, 3, 4, 5, 6. That 6 is a long chain. Then we have 1, 2, 3, 4, 5, 6. If you go right to left, you could also start at this this carbon that's up at the top here. So 1, 2, 3, 4, 5, 6. So we have 3 sets of options that have 6 carbons. So I'll label them here to illustrate what I'm talking about. So we can throw out the first option right away because if we look at this 1, 2, 3, 4, 5, 6, if we consider rule number 2, which is the lowest numbering system, that our branches need to be at the lowest possible number, then this has a branch 1, 2, 3, 4. It has it at the 4th position, which all of these other ones have the first branch at 2 or at 3 in the other option. So right away you can remove that one. Now, when we go to the lowest numbering system for these two, the one in orange has the first branch at 2. The one in blue has the first branch at 3. So again, using lowest numbering system, we can throw out the blue option. It has to be orange. So now I'll redraw this and then keep the orange numbering system since we just identified that that is the only correct one. So this is 1, 2, 3, 4, 5, and 6. So now 6, again, if you go back to our list, 6 is hex. This is a alkane, so it's hexane. Now we need to name the branches. So how many carbons are involved in our branches? Well, at 2, there's only one carbon that's a branch. So our branches are abbreviated in the generic name as alkyl. Again, where the alk is just a placeholder for the number of carbons, the YL indicates that it's a substituent. So here, the alk becomes meth for this first branch. So this one becomes a meth YL, so a methyl group, and it's at the 2 position in our chain. So it would be a 2-methyl that we have identified at the 2 position. Then the other carbon chain that's a branch here is 2 carbons long. So that is F, and it's ethyl because it's a branch, and it's at the 3rd position in our chain, so it is a 3-ethyl. So now we've named everything of our molecule. Now we just have to put it together into our final name, that our systematic name. So this is where we have to use rule number 3, which is that substituents are listed in alphabetical order. So we list our substituents out in alphabetical order where we're comparing E to M. E is first in the alphabet compared to M. So this final name then is 3-ethyl 2-methyl hexane. And the methyl and hexane is just one word. You don't put a space or anything there. You always put hyphens between numbers and letters. That's why you see a 3-ethyl -2 -methyl hexane. And that gives you the final IUPAC name for this example. All right, for the remainder of the video, we are going to take a look at a series of examples and just continue practicing this. So our question here is just name all the following compounds by IUPAC naming convention. So again, the first rule is determine the longest chain. So if we just go like reading left to right, it'd be 1, 2, 3, 4, 5, 6, 7. We can go right to left, 1, 2, 3, 4, 5, 6, 7. We can also start at the ethyl group. So 1, 2, 3, 4, 5, 6. 6 is less than 7, so it has to be the 7 is the longest chain. And there's no difference if you go left to right or right to left in this case because of the symmetry of the molecule. So there is our 7 longest chain. So that is hept. This is a heptane because the molecule is just an alkane. There's no other functionality here. Then we need to consider our branches at carbons 1 and 6 and 4. The carbons at 2 and 6 and 4. The ones at 2 and 6 are both methyls because they have one carbon. So they are methyls. Now, whenever you have multiple substituents that are identical, you'll need a prefix to the prefix of the number here. So in this case, it's going to be 2,6 and then dimethyl, where the di is the prefix to the carbon prefix. So di means that there's 2 of the exact same group, and that's why we use these normal Greek prefixes of di, tri, tetra, penta, etc. that indicate this. So this is a 2,6 dimethyl. Now, if you're wondering, does that have an implication on rule number 3? These additional prefixes do not count in the alphabetical order. It's still just the carbon prefix. So if you had to compare a dimethyl to an ethyl group, the ethyl still has priority because E comes before M. It doesn't matter that you have a D in the dimethyl. Okay, and then at 4, we have an ethyl group. Nothing fancy with this one. There's 2 carbons, so F, and then it's a branch, so YL. So now we put this all together, and like I just said, we don't consider the the di in our alphabetical naming convention. So this has to be then 4-ethyl, then 2,6-dimethyl heptane, all one word. Okay. Moving to the next example. All right, so this is basically the exact same molecule. So our longest chain is still 7. So now the question just becomes, which has priority, this fluorine group, or the methyl group at 6? So again, when you have a choice like this, when the lowest numbering system would be the same in either case, so if I go right to left, it would put the methyl group at 2 or the fluorine group at 2. Then when you have a situation like this, it's always alphabetical order. So F becomes before M in the alphabet, so fluoro goes first. Whenever you have an alkane, a haloalkane, I should say, the halide is just a halo is the prefix name for it. So in this case, the fluorine is going to be a fluoro, where you just drop the INE of the element name and you add an O for what we consider here halo. And then it's at the 2 position, so this is a 2-fluoro compound. And like we saw before, this is a heptane because of the 7 carbons in the longest chain. There is a 4-ethyl still, with the hyphen here, because of the 2-carbon branch. And then now there is a 6-methyl, and it's not a dimethyl now because the fluoro breaks that symmetry there that caused for the additional prefix. So now again, alphabetical order when you put this all together. So the ethyl group goes first because E is before F in the alphabet. So this becomes 4-ethyl, 2-fluoro, 6-methyl heptane. Again, all one word at the end. All right, here we have another question. So again, the rules are the same. Identify the longest chain. Our functional group here is again simply an alkane, so nothing changes in our functionality there. So now it's a matter of identifying what is the longest continuous chain. So if we start at going left to right, it'd be 1, 2, 3, 4, 5, 6, 7. 7 is a pretty long chain, so that might be it. We could also go up to this branch here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is longer than 7, so we have to consider that one. Then you could go from this ethyl group all the way up, so 1, 2, 3, 4, 5, 6, 7. 7 is still less than 9. Or you can go 1, 2, 3, 4, 5, 6, 7. Again, 7 is less than 9. So we have to go from left and then up, if you will, like that. You may wonder why you don't start at what I've labeled as 9 and go down. Well, if you do that, again, it's rule number 2 that the lowest numbering system rather would not be satisfied in that case, because you would put your first substituent 1, 2, 3 at 4, and here our first substituent is at 2. So that's simply why this wins. This is a better system by our nomenclature rules. Okay, so now at carbon 1, or excuse me, at carbon 2, there's a 1-carbon branch, that's a methyl. 1-carbon branch, that's a methyl. And at 6, there's a 1-carbon branch, that's a methyl. So those are all the same. So this is now a 2,2,6 trimethyl, because now we have a prefix to the carbon prefix again, where it's tri because there's 3 groups. Then simply at carbon 5, we just have another ethyl group. So 5-ethyl, and that is it. So, and then our base name is 9 carbons, so that is a nonane, where 9 is the known, ane is because it's an alkane, and that is the whole name. So now alphabetical order again, ethyl comes first, so 5-ethyl, 2,2,6 trimethyl heptane. Okay. Moving on to the next example. So here, again, longest numbering system, or the longest chain of continuous carbon. So 1, 2, 3, 4, 5, 6, 7, if we go like that, from left to right, like reading. If you go right to left, 1, 2, 3, 4, 5, 6, 7, it puts the substituent at the exact same position, so there's no preference there. If you go 1, 2, 3, 4, 5, 6 up into the substituent, 6 is less than 7. So the longest chain is 7, and the numbering system could either be left or right in this case. There is no difference. So now 7 is heptane, hept for 7, ane because it's an alkane. And then at 4, we have this group that's called isopropyl. So if you didn't know that, there's 2 acceptable ways to name this. One is the isopropyl route. So I'll start with that and just call this group 4-isopropyl. So we know that prop is for 3. So it's called isopropyl because it has the branch at the 2 positions. So this is 1, 2, 3 carbons, and then 2 of that position is what's binding, and that's why we get the isopropyl. But you don't have to name this by isopropyl. You could do this complex naming idea in IUPAC naming convention, where you can identify the group based on the chain that you have within the branch itself. So what I mean, let me redraw this and show you what I mean. So at carbon 4 that we've identified here is the one in the middle. Our longest continuous chain in the branch is a 2-carbon branch, right? Because here's where it's bound directly, and then we either have 1 additional carbon going off to the right or to the left. So that's an ethyl group, a standard ethyl group that I've listed there, right? So let's start with that. There's a standard ethyl group. Then at the 1 position in that ethyl group, there is a methyl. So that's this part. This is a 1-carbon branch within the branch. So this is then, and it's at 1 in the chain of the branch. So here it's 1 in blue because it's referring to this one of the ethyl group, and then meth and YL because it's a branch within the branch of the ethyl, right? So this is basically like a substituent inside of the substituent. So 1 because it's at the 1 position in this branch, methyl because there's 1 carbon and it's attached to that 1 position in the ethyl group. So then it becomes a 1-methyl ethyl group. That is the same as an isopropyl group. So the 2 ways that you can correctly name this by IUPAC is in parentheses for this complex naming system, 1-methyl ethyl heptane, or you can say 4-isopropyl heptane. Both are acceptable. It's up to preference which one you would like to use. All right, here we have another question. So again, this is simply an alkane, no additional functionality here. So now we have to look for our longest continuous chain. So we have a couple options, 1, 2, 3, 4, 5, 6, going left to right, 1, 2, 3, 4, 5, 6, going left and up. So now we have to determine which is better. We know if we go 1, 2, 3, 4, 5, 6, there is a better numbering system if we go right to left. So 1, 2, 3, 4, 5, 6, right? And that leaves us with 1 substituent. Or we can go the other way, where you start at the top of that substituent. So 1, 2, 3, 4, 5, 6. These are both 6. And this one has the lowest number at 3. This one has the lowest number at 2. So this gets the preference. Another rule for this, like kind of a hidden rule in IUPAC, is that if you have 2 chains that have no difference in the lowest numbering system, then you pick one that has more substituents. In this case, that's not the biggest reason because our lowest numbering system is followed by this molecule and not by the other naming convention. So that's the best reason here. But just so you know, there are examples like I mentioned. So here then 6 is hex, and it's an alkane, so it's a hexane. And then at 2, there's a standard methyl group, right, because of the 1 carbon here. And then at 3, it's a standard methyl group because of the 2 carbons at that position. So then, again, you use the alphabetical order naming system. So this is then 3-ethyl, 2-methyl, hexane. Okay? And that is that one. Moving on to the next question. So here, it appears that we have 2 T-butyl groups, if you're familiar with this type of substituent here, but you would be incorrect because you have to be very careful about determining the longest chain, right? So if you go 1, 2, 3, 4, 5, 6, you would think it's a hexane and you would move on. But you have to start in the chains here in this case. So if you go 1, 2, 3, 4, 5, 6, 7, 8, that's 8. 8 is longer than 6, so you have to number it that way. So if you thought that this was a di-T-butyl group or molecule, that is a mistake here because of rule number 1. So be careful when you're looking at this. So this is the correct numbering system. You may wonder why I went from up to down. You could go down to up, equally correct because of the symmetry again of this molecule. So now if we look at 2, we have a methyl group, and at 2 we have a methyl group, and at 3 that's a methyl group, 6 that's a methyl group, 7 is a methyl, and 7 is a methyl. So when you put that all together, this is a 2, 2, 3, 6, 7, 7, and then 1, 2, 3, 4, 5, 6, hexa, hexa for 6, hexa, and then a methyl because of the 1 carbon branch. So that entire thing is a 2, 2, 3, 6, 7, 7 hexamethyl, and then it's simply an octane because there's 8 carbons in the longest chain, and again it's an alkane, so you just use the ane suffix. So then there's no difference in alphabetical order here, you just list this very long substituent as 2, 2, 3, 6, 7, 7 hexa methyl octane. All right, here we have our last set of questions. So again, this is simply an alkane. It has chloro groups. It has these halogens that we need to also address, but they're just simply substituents. So now the question is, what's the longest chain? Well, it could be 1, 2, 3, 4, 5, 6 if we go left to right, or it could be 1, 2, 3, 4, 5, 6. And now we need to decide which is correct. So here is an option. And then let's draw the other option. Okay, there's our molecule, and then the other option would be 1, 2, starting kind of in the substituent. That would be the option there. Or you can have these, don't forget about these methyl groups here off to the side, right? So this is actually not the longest possible chain because you can continue to the methyls as well. And I missed this as I was drawing it. So this is an instructive point here. Always be very careful when you're looking at these molecules to look very critically for the longest chain. So what I realized is that if you go start this methyl group as 1, then 2, then 3, 4, 5, 6, 7, and then 8, you now have the longest chain of 8 again, which is much better than 6. So the other 2 options are not as good as this one, and they are then ruled out. So using that then, now at 2, there is a methyl group, 3, there's a methyl group, 6, there's a methyl group, and 7, there's a methyl group. So that is 2, 3, 6, 7, tetramethyl, all one word. I'm kind of showing it as 2 just because of space. And then there's a chlorine at 2 and at 7. So 2,7 dichlorine. chloro. Okay, and then again, you put this all together in one combined name, alphabetical order. So this is 2,7-dichloro. The chlorine substituent goes first. Then you list the tetramethyl substituent, so 2,3,6,7 tetramethyl. Again, all one word, but I'm out of space here. And then it's simply the longest chain, which is octane. So this all put together is 2,7-dichloro 2,3,6,7 tetramethyl octane. And then here is our very last question for this video. Again, it's simply an alkane, so you just look for the longest chain. And there's 6 a couple different ways. You can have 6 if you go 1, 2, 3, 4, 5, 6, or if you go 1, 2, 3, 4, 5, 6. So now the question is, if you start with 1 at the top by the chlorines, that is better for lowest numbering system, simply because you have these substituents at 1, which is the lowest number possible. So that is the better option. So then at 1 and 6, there are 3 chlorines, right? These 3. So then this is a 1,1,1,6,6,6 hexachloro compound. And then at 2 and 5, there are methyl groups. So it's 2,5-dimethyl. That is this position and this position. And then it's a hexane because it is 6 carbons is the longest continuous chain. So you put this all together. It is a 1,1,1,6,6,6 hexachloro 2,5-dimethyl hexane. All right, that is all I have for this video. So I hope you found it helpful and you learned something. If you did, please leave a like and subscribe to the channel for more content like this. If you have a topic suggestion or any suggestion for the channel in general, feel free to leave it in the comment section below. And with that, I'll see you all in the next video, and I hope you have a great day.